Thank you for inviting me to CS-NOG and to Brno. It's actually, I think, the second or third time I've been to Brno, but I was working on a project here for a number of years, a few years ago, so it's a reasonably familiar place. But I'm here to talk about MANRS, or Mutually Agreed Norms for Routing Security. This is an initiative that is being supported by the Internet Society, but we very much see this as a community-sourced and community-involved activity. So whilst there's an Internet Society slide, again, please see this as something that we would like the community to be very much involved with. So just to give you a background, I'm not going to get into really a lot of details of how BGP works. We're at a NOG, you're network engineers, presumably you know about this. I hope you know about this. But just to give a sort of very quick overview, there are just over 64,000 ASs on the internet as of about a week ago. Obviously, the AS number is used to identify a network, and those ASs are used to identify networks to each other as well. Probably the important statistic is there's about 10,000 multi-homed ASs, so you'd expect about 54,000 stub networks, so they can be partly disregarded in this respect. So it's really the 10,000 multi-homed ASs that we're concerned with. As you know, BGP is pretty much based entirely on unverified trust between networks. Whilst RPKI has been introduced, and there's some other things that have been done over the years, pretty much inherently there is no built-in validation that the BGP updates are legitimate. And this chain of trust is spanning the whole world, the whole globe. And really, when it comes down to it, network operators don't exactly know who they're talking to, or they can't necessarily prove who they're talking to. This means, as a result, there are some bad actors, there are also misconfigurations, and the routing system really is under attack and is really a vulnerable point of the internet. So how big is this problem? Well, so there's really three types of routing incident. You have the prefix and route hijacking. This is where a network operator or attacker is pretending to be another network operator, pretending that their server or network is their client. This can end up with packets being forwarded to the wrong place. It can be used for denial of service attacks, can be used for traffic interception. Obviously, the very famous incident was the 2008 YouTube hijack, but more recently there was an Amazon, the Amazon Route 53 hijack as well. Very similar to a route hijack is a route leak. Again, this is more of an accidental misconfiguration where a network operator accidentally announces to an upstream provider that they have a route to a destination that they don't have. But this can be used for a man-in-the-middle attack. It can be used for traffic inspection and reconnaissance. There's a known incident, well-known incident back in 2014 where Volume Drive began announcing BGP routes from Cogent, and that caused disruptions in many places across the internet. So I think the point is that when there are these either hijacks or route leaks, they can have disruption way beyond the network operator itself, and in fact can have very significant regional, if not global, implications as well. Then finally we have IP address spoofing. This is where someone creates IP packets with a false source IP address. That's often used to hide the identity of the sender or to impersonate another system. And this is the root cause for reflection DDoS attacks. Again, fairly recently, the mem-cached reflection amplification attack directed at Akamai, which was a big one that was received a lot of reports. But these are happening every day. Those are the well-known ones. Just as a sample, in the first 5 months of 2018, there were nearly 14,000 incidents or suspected incidents. and about 10% of all autonomous systems on the internet were affected by that. It should be said that most network operators are responsible and do the right thing. And in fact, a lot of these incidents are caused by a relatively small number of bad actors or people that really maybe aren't entirely sure what they're doing. But it gives you an idea of the scale of this. And this is going on every day. So just a sample for I think this is about the first 8 months of 2017. There is literally hundreds of attacks sometimes every day. This is ongoing. So this is where MANRS comes in. So this is aiming to provide some fixes to eliminate a lot of these common threats to the routing system. And this really isn't anything new, nothing new under the sun. But it's trying to bring together a number of established industry practices into sort of one package so that network operators can implement this and hopefully address some of the problems that we see with the routing system. And it's really based on collaboration amongst participants and those network operators taking a shared responsibility for the internet infrastructure. So the more people that join and the more people that employ these practices, hopefully the better or it will reduce the problem of these routing incidents. So these 4 actions, these will probably be very familiar to you, most of them. So prefix and AS filtering, so that's preventing the propagation of incorrect routing information. So only announce what you're entitled to announce. We've got anti-spoofing, action number 2. So that's preventing traffic with spoofed source IP addresses emanating from your networks. This is a bit more complicated than it sounds, but certainly for stub networks, it should be good practice to do this. Action number 3 is coordination. So this is facilitating communication between network operators. So making sure your contact details and your resources are listed in a global database. So that would typically be the RIPE database and peering DB, for example. Then we have global validation. So this is really 2 things. One is making sure your routes are entered into a IRR. And then also we're looking at implementing RPKI, so having ROAs for your address prefixes. The RPKI is not compulsory for MANRS, but it's a recommended action, and I'll come on to that in a moment. We heard about RPKI yesterday, I think. So the point is, everybody, although implementing these things don't necessarily gain you anything immediately, if more people do it, you're joining a security-minded community of operators, and this will hopefully make the whole routing system more robust. It will also help when the incidents do occur. It will help networks identify where those problems are and also be able to contact your customers or peers, contact your customers or peers more easily, make sure you've got the good contact information. And then, as I said, consistent adoption. We are starting to see some small improvements here. We have relatively small number of participants at the moment, but even with that small number, actually we're starting to have an impact there. Okay, so where we are at the moment, so we have 155 network operators that are participating. I'm going to focus on the Czech situation in a moment. Those 155 network operators, some of those are operating more than one AS number, so that represents 279 ASs at the moment. And we also have 32 IXPs participating in this program. There are actually separate actions for the IXPs, but I'll come to that towards the end of the presentation. Then we have 10 other partners, such as a RIPE NCC and APNIC, who are helping us with promotion and training and that type of thing. So, how are we doing in the Czech Republic? actually, I must apologise. I didn't realise this was a Czech and Slovak NOG, so I didn't do the figures for Slovakia. So apologies for that, but I hope you get the idea. I should have realised that CS was the old country code for Czechoslovakia, but I completely admitted that, so apologies. I counted 714 ASs assigned to the Czech Republic. And there is at the moment precisely one ASN participating in MANRS, who is VS Hosting. I don't know if they're in the room, but well done to them. Well done, that man. Oh yeah, I know you. And they've implemented all 4 actions, so that's good. But when I looked at this, I actually found that many of the Czech ASs are actually already MANRS conformant, and I will show you some examples of that in a moment. But how to implement MANRS? Well, okay, if you haven't implemented MANRS yet, which is most of you, it seems, we do have some implementation guidance. This is based on some BCOP practices, which have been developed and deployed by operators around the world. We put this document together, so it goes through action by action, the steps you should take to implement MANRS and some of the recommendations there. And this document's actually been recognized by the RIPE community and published as a RIPE 706. RIPE 706 is actually the abridged version, but it does have a link to the full document. So if you're interested, go to that URL. Okay, but something else we've been developing for the last year is a tool really to benchmark ASs and to give you a sort of visual display of how well you're doing and whether you're implementing routing security practices. And you can also look at other networks, or at least at the moment it's other countries, other regions, and you can look at those to see how well they're doing. The aim is to eventually, and when I say eventually I mean quite soon, you'll be able to look at every network in the world, every AS in the world, and see how they're performing routing security. The other aim is to provide, basically a record of the state of routing security over time. So can you check whether routing security is getting better or worse? So it helps with the problem statement. I showed you some of the statistics from last year, and this is very much designed to be a dynamic time running system. And it's also there to help MANRS participants easily check if they have any problems. So you can look very easily, you can look at your network and see, okay, do I have any problems and what are they? This is all based on, so this is all done passively, there's no active measurements, and this is all coming from publicly available sources. So primarily BGP Stream, the CIDR report, you have the CADA spoofer database, and then various public WHOIS databases and IRRs as well. So I was thinking of giving a live demo of this, but you know how demos can go wrong, and I wasn't sure about connectivity here or on this laptop. So I've done some screenshots, but it hopefully gives you an idea, a basic idea of what's possible. So this is a state of the global. This is a global view of routing security in the month of April. It gives you a record of how many incidents there were, or how many suspected incidents, how many networks caused the problem, and then how are networks doing in terms of putting their information into routing databases or into WHOIS databases, and also how they're doing in RPKI. Now, I will point out that we've been testing this system and we've had some data issues. So I actually do not believe the whole world is at 100% for route filtering, I'm afraid. But that's probably a glitch in the data. But normally that will show a percentage based on the analysis coming from the CIDR report and BGP Stream. Anti-spoofing, that's another figure, so that's probably correct, but I'll explain that a little bit more. So then in terms of coordination, how many networks have put their information into a WHOIS database, that's about 89%, so it's pretty good. With respect to IRRs, again, most networks in the world are doing the right thing and putting their routes into an IRR. And then RPKI, the situation is less good, and I think this was touched upon yesterday. Only 9% of networks have ROAs for their prefixes. So you can also do this analysis by country. You can do it by region as well. So you can do it by RIR region, UN region, sub-region, country. It's not amazingly useful information, but it can give you an overview for a country if you're interested in that. But you can drill down into the details for individual networks with this as well. So here's an overview of the Czech Republic. And actually, things are pretty good here, I have to say. Really good. 100% filtering. For coordination, 100%. Global validation is 98%. And actually, even for RPKA, it's 22%. So quite impressive figures. I actually didn't entirely believe this. I went and randomly checked some individual operators, and actually, it's pretty much right, I think. I'm not going to say this is 100%, but it's not far off. I should say with the anti-spoofing, why is that 60%? Well, that requires some active measurement from the some active action from the networks themselves. They need to run the CADA spoofer tool, and that basically sends traffic from your network, and traffic gets sent back, and CADA does some record of how many spoof packets are recorded. 60% usually means that a test hasn't been run from a network segment. So I have a bit of an issue with this, the way this is displayed. I think we need to look at this again, but it doesn't mean to say that it's only a 60% success rate. That just means that all the tests haven't been completely run. Then you can look at this data over historically. I think this is for the Czech Republic again. So, in terms of incidents, we might say there's been since September last year when we started this and started recording the data, there's been a slight decrease probably in incidents. Weirdly, the number of culprits seems to have gone up. I'm not sure why. Good figures for routing completeness, and then RPKI. Okay, there's another glitch in the data here because until the beginning of this year, we didn't have all of the data compiled. So this is why it goes from, looks like nearly 100% validity down to whatever it is, 22%. That's just simply because we got more accurate data and compiled that into the results. So when this goes live to the public, we'll take all this old stuff out and just go with the results that we know are fresh. And then you can see, how well each network is doing for each of these categories per month as well. That's the bottom of the page. So again, you can see the data glitch there with the RPKI, but please be aware this is a beta test at the moment, so we're ironing some of these problems out. Okay, so you can also look at data for individual networks here. So this is the top. This is ordered by AS. So I guess DHLnet was probably an early network in the Czech Republic, and Chestnet certainly was. So that's probably why they have a low AS number. And again, you can see it's a pretty good record. I think I can see NIC-CZ there. They would be MANRS conformant. Chestnet is MANRS conformant. I think pretty much everyone on this screen is potentially MANRS conformant. So maybe not GTSC, T-Mobile, Czech Republic, but okay, that's a glitch there for them. But I don't want to pick anyone out individually, but it's a good show really from this country. I would say, again, reiterate global validation for RPKI. That's not a compulsory MANRS action. That's really for information. It may become a compulsory MANRS action at some point. We're discussing that at the moment. Okay, and then you can drill down. So going back to this screen, you can actually click on the AS and you can drill down into more information. So this is for Chestnet, and I did ask their permission if I could show this because they are interested in joining MANRS, and they're conformant, so they can join MANRS. So you can look at for each of our metrics. So we have a number of metrics we use to compile the dashboard. and really this is interesting. If you do have something where there's an issue, you can spot this pretty well. Chestnut doesn't have any issues. The only thing that I can spot is the number of prefixes that have valid rowers. So they have 23 prefixes with valid rowers and 4 without or unknown. When I spoke with Andre, he said, well, that's because they've actually aggregated other prefixes which do have rowers, but obviously the rower isn't valid then for the aggregated prefix. So that explains why that 4, there's that 4, figure 4 there. So it needs to be, you need to be aware when you interpret this data that just if something's not at 100%, there may be reasons why it's not at 100%, but at least it lets you look at if there are problems, you can see where those problems are and why this has been flagged. And that's really the idea behind this. So as I said, we've just launched the beta test with the MANRS participants only. We want to get them familiar with this. We want to iron out any problems. You've already seen some of the problems, but you know we know what they are. And we really want to aim to launch this publicly later in the year. That's the aim. It's not 100% decided what levels of access would be available to the participants and the public. In the beta test, all of the participants can look at the data from all of the other participants, but the public can't look at that data at the moment. So we're restricting that until we've made a decision on this. It may be that the public can only see aggregated overviews and not individual network data. We would encourage the participants to show the individual data because this is actually all public anyway. It's coming from public databases. People can find this out if they want to. But this is all, obviously, you know, you have to be a bit careful at how you interpret some of the figures. And there are some false positives at the moment. So with BGP stream, it sometimes is guessing whether something is an incident or it may just be a false positive. And as I highlighted with Chestnut, it's a very good example with Chestnut. There's sometimes good reasons for non-100% conformancy. So, they've done exactly the right thing by aggregating prefixes, but of course that breaks the RPKI. So, what do you do? That's something that maybe we need to think about. Okay, just want to mention the MANRS IXP program. So we're also encouraging IXPs to sign up to MANRS. They have a slightly different set of actions. Again, preventing the propagation of incorrect routing information, which is very standard stuff. We have action 2, so that's actually promoting MANRS to their IXP membership. So really, they encourage their members to sign up to the routing security principles. And I will add, some people don't want to join MANRS, but we would encourage you to employ these routing security principles anyway. In the Czech Republic, it seems pretty much everyone is doing the right thing. So, that's good, and that's really what we're trying to get to in the end. So action 3 is protecting the peering platform. That's really layer 2 stuff. So sort of the shall I say rules or the procedures for exchanging layer 2 traffic. Action 4 is pretty much the same. So for making sure that all the members are providing contact information in the various databases. And then there's an action 5 in this case for IXPs, which is providing some monitoring and debugging tools. So as I said, is the problem getting better or worse? So this is a global view, which I took a snapshot just before I came. You might argue the number of incidents are slightly on the decrease. The number of culprits is similar problems, I would say. Nothing much has changed on that aspect. But what is quite positive, and you have to bear in mind there could be some data glitches here at the moment, but you're seeing that there's been an improvement in the number of network operators who are registering their routes in IRRs. So you can actually see a clear sign there. And And also even with RPKI, you know, the number of valid rowers is you can see, well, actually a distinct upturn actually. I mean, it's still quite low, but you can definitely see an improvement there. So the situation is improving. Whether this is down to MANRS, who knows? But at least there's growing awareness that these practices should be implemented. Okay, so the point is, my last point, you know, MANRS needs to be this collaborative initiative. You know, Internet 2 is supporting this, but it needs to be driven by the network operators themselves. Ultimately, the operators have to implement these routing security practices, and actually, we need your input to decide. We need your input to decide, you know, how we go forward with this. So we're looking to amend some of the actions. We're looking maybe to introduce RPKI as one of the MANRS actions. You know, we don't know if this is the right thing to do. I use the chestnut example. There may be good reasons why you can't do RPKI, and this is why we need feedback and input, and you know, basically the community making these decisions. But we're also working on updating the implementation guides. We're creating a new implementation guide for IXPs. That's actually happening through the right BCOP task force. So if you're interested, and I think there's at least several IXPs in this room, if you're interested, we'd be very interested in your participation. We're also developing training materials as well. So again, anybody interested in contributing to that. But we really need the operators to go out and talk about, well, operators and IXPs to go out and you know, talk about this and say, tell their members, tell their operators why this is important to implement these routing security measures. We've got some presentations you can use. We've got lots of merchandise that you can hand out. So if you have an event and you want to promote this at one of your events, we're happy to send out all the goodies for this. If you're interested in joining, go to that URL, fill out the form. We'll get back to you. We'll check for conformancy. As I say, I think nearly all the operators are conformant in the Czech Republic, so we'd really encourage everyone to be involved. This doesn't cost anything; it's free. And then you can participate in the observatory. You can participate in the MANRS decision-making process as well. So that's it from me.
Thank you very much. If there are any questions, please come forward. And we can try to switch to Slido if there are some questions, I guess. Okay. So last chance for questions from audience. Okay, thank you very much for the presentation.